Welcome to another video, and this video is focusing on maths again, and to be specific, I'm focusing on high school mathematics, and I'm be dealing with algebra today. So I have two intriguing questions. Please feel free to stop this video, attempt the questions, and get back to the video to look at the solutions. So question 1 says, given a plus b equals 7 and ab is equal to 6, without finding the numerical values of a and b, determine the numerical value of a squared plus b squared, b, a minus b. Now, our solution is as follows. Question 1, a. Looking at these squares here, the question is suggesting that we have to square this. That's the only way we're going to get a squared plus b squared. But what we do on one side of the equation, we have to do the same on the other side of the equation. So a plus b, I have to square this, and I must get 7, which must also be squared. The left side, or left-hand side, is a plus b in one bracket, another bracket a plus b again. And 7 times 7 is 49. Now, the left-hand side here, how you expand this, in the first bracket, we have a plus b. That means a must multiply with the second bracket, a plus b. And then what is remaining is plus b. It has to multiply with the second bracket, a plus b as well. This is equal to 49. Expanding the first bracket, we get a times a is a squared, and a times b is ab, plus b times a is another ab, and then plus b times b is equal to b squared, equals 49. These two terms are like terms. It's actually one term. So let's put them together. We get a squared plus ab is 2ab, and then plus b squared equals 49. Excuse me. Now, let's look at this expression again. What this expression is saying is that if you have the square of a bracketed expression, to simplify or to expand it, you take the first part, the first term, multiply by itself, you get a squared in this case. And then you take the first and the second term, the two terms in the brackets, multiply them, you get ab. But you gotta double it. We have a plus sign here, so we have to maintain that plus sign. If we had a minus sign here, this would be minus. So finally, we have to take b and multiply by itself, you get b squared. This is critical because in the coming examples, you'll see that this becomes very, very paramount. So now we put together what we want to find, which is a squared plus b squared, and then plus 2. We are told what ab is. Ab is 6. If you check here in the given information, up here, ab is equal to 6. So we must put 6 in that set of brackets, and this gives us a squared plus b squared plus 12 is equal to 49. And so what we do next is to take 12 to the other side, or you simply subtract 12 from both sides. So you get a squared plus b squared. If you subtract 12 from the left hand side, 12 is gone. If you subtract 12 from the right hand side, you get 49 minus 12. And so a squared plus b squared is actually equal to 37. So we have been able to determine the value of a squared plus b squared without finding the numerical value of a and b. The question says, without finding the numerical values of a and b, determine the numerical value of a squared plus b squared in part A. So this is the numerical value of a squared plus b squared, and we've been able to determine that without finding the numerical values of a and b. Part 1. So we're going to need this solution here in the second part. Part 2, or question 1, b, it says we need to determine the value of a minus b. Now, if you look at a minus b here, has no direct connection to a plus b or ab. However, if you square a minus b, something nice comes up. So b, a minus b, we square this, what do we get? Remember what I said over here? You take that, multiply by itself, take these two, multiply them together and double it, respecting that sign in the center, and then b times itself gives you b squared. So in this case, we're going to have a times a is a squared, a times minus b is minus ab, but you gotta double it, and then b times b obviously is b squared. Now we have something very interesting here, which is the fact that a squared plus b squared, we know the value of that, minus 2, we have a, b, if you like, put it in brackets like that, it will be easier. What is a squared plus b squared? Well, we had a squared plus b squared here as 37, and therefore we must have 37 here minus 2. The value of ab has been given in the starting step there, or starting at the beginning of question 1. We are told that ab is 6, so we have to put 6 there. So this gives us 37 minus 12, which is equal to 25. Where are you coming from? You're coming from a minus b squared, a minus b squared, a minus b squared, and indeed a minus b squared. At this stage, it looks good to take square root on both sides. So we're going to say square root of a minus b squared. Remember to put plus or minus on the right hand side because we're dealing with a quadratic equation here. This cancels that. What do we have on the left hand side? A minus b is equal to plus or minus 5. Yet again, we've been able to determine the value of the required expression, the numerical value of the required expression, which is a minus b, without finding the numerical values of a and b. That marks the end of question 1 of these part 1 of intriguing questions. Surely, God willing, shall come back with part 2 of these intriguing questions in algebra. Question number 2 says, given x plus 1 over x is equal to 3, and we're told that x is not equal to 0, we are also told that x is a real number. What are we required to find? Without finding the numerical value of x, determine the numerical value of a, x squared plus 1 over x, b, x cubed plus 1 over x cubed. Again, this question is suggesting that we have to square both sides of this given piece of information. So question number 2, our solution is as follows. A, we are told that x plus 1 over x is equal to 3. So we're going to square both sides. X plus 1 over x equals 3 squared. Applying the same principle I've explained in example 1, we're going to take this multiply by itself, we get that. This multiply by that, be careful here, we have to double, but we have to say x times 1 over x. Multiply these two and double it. The plus sign there, respect it. 1 over x times 1 over x, it's going to be 1 over x squared, and is equal to 9. Now, what do we do next? We notice something here, that this x cancels that x. So here we have 2 times 1. So x squared plus 2 times 1 is 2 plus 1 over x squared. Because when you square 1, you get 1. You square x, you get x squared, equals 9. Now, let's pull together what we want to find, which is x squared plus 1 over x squared is equal to, subtract 2 from both sides, you're going to get 9 minus 2. So what do we have now? We have x squared plus 1 over x squared, and the answer is 7. Do we know what the value of x is? No, we don't. We don't have to, because the question says without finding the numerical value of x. So that's our solution for part A. Part B, looking at cubes, x cubed plus 1 over x cubed, it clearly means that we have to cube both sides of the given piece of information. So let me start over here. We know what we're doing, we want, and part B, what we want is x plus 1 over x. We have to cube this. The answer will be equal to 3 cubed. And cubing this, be careful, x plus 1 over x in one bracket. The other bracket must contain x plus 1 over x. Everybody must be squared. Everybody must be squared. In other words, square the whole of this expression is equal to 27 when you cube 3. Now, what do we do next? This part here has already been worked out. If you check, it's this expression over here. So now I have x plus 1 over x multiplied this by the whole expression, which is x squared plus 2 plus 1 over x squared, and this should be 27. Now I have to expand this here. Expanding that expression gives us the following. We take the x, this one here, multiply by the entire of the second bracket, which is x squared plus 2 plus 1 over x squared, and what is remaining in the first bracket is 1 over x. Again, I have to multiply that by the entire of the second bracket, which is x squared plus 2 plus 1 over x squared, and the whole of this should be equal to 27. Right. Now at this stage, we have to do the expansion again. This implies x times x squared is x cubed. X times 2 is 2x. Be careful here now. X times 1 over x squared, x times 1 over x squared, x cancels 1x, you're left with 1 over x there. Be careful. Plus, multiplying these two, I have to be careful as well. 1 over x times x squared, and then this times that, obviously it's just going to be times 2 of this. In other words, 1 over x times 2, we get 2 over x. And then this times this, in other words, 1 over x times 1 over x squared. 1 times 1, the answer is 1. All over x times x squared is x cubed. The whole expression must be equal to 27. Right. Let me remove this one for a minute. So now this is what we have. So let's clean up. X cubed plus 2x plus, we said here 1 over x, plus this x cancels 1x there, you're left with x, plus 2 over x plus 1 over x cubed equals 27. Let's put like terms together. What do we have? So we have x cubed. These two are like terms, and those two are like terms. So x 2x plus x, the answer is 3x, plus 1 over x plus 2 over x. Obviously the denominator is the same, you have to add the numerators, so that will be 3 over x plus 1 over x cubed, and the answer is 27. Now factorizing this expression here, we get something nice. So first, x cubed plus 1 over x cubed, because that's what we're looking for, plus, so I'm putting basically this expression and that expression together like so, and then this part here, the common factor is 3, open brackets, 3 into 3x is x, plus 3 into 3 over x is 1 over x, is equal to 27. This part here, remember, this is where we started from. x plus 1 over x has been given here at the beginning as 3. You can also see it on the question paper itself. X plus 1 over x equals 3. So we put 3 here. What do we get? We get x cubed plus 1 over x cubed plus 3 times 3 equals 27. So if you work out this part here, that's 9. So it's x cubed plus 1 over x cubed plus 9 equals 27. Subtract 9 from both sides. You're going to get x cubed plus 1 over x cubed is equal to 27 minus 9. Simplifying the right hand side, you're going to get what we want to find, which is 27 minus 9. The answer is 18. So yet again, we've been able to determine what they wanted us to find, which is the numerical value of x cubed plus 1 over x cubed, which is equal to 18, without actually knowing what x is, because the question says without finding the numerical value of x, determine the value of x cubed plus 1 over x cubed. That's what the question says. This marks the end of this video. I hope it was useful and helpful. If you're new to this channel, please subscribe, share these videos, like these videos. It will go a long way in helping grow this channel. God bless you. See you in the next video.